We will begin our review of agricultural chemistry by looking at the structure of the atom. The atom is the basic building block of all matter. Everything material in the universe is made up of atoms or parts of atoms. People, plants, animals, water, trees, mountains, and even the clouds in the sky are all made up of atoms. You will probably remember that the atom is made up of three basic particles: the proton, the neutron, and the electron. The proton and neutron are virtually the same size and weight, with the neutron weighing just a tiny bit more than the proton. But the electron is much smaller than the proton or neutron. As a matter of fact, it would take 1,840 electrons to equal the weight of one proton. The proton has a positive electrical charge, but the neutron has no charge at all. It's neutral, and that's why it's named the neutron. The electron, as you would guess from its name, does have an electrical charge, but it is the opposite of the proton. The electron has a negative electrical charge. Both the proton and the neutron are located at the center of the atom and make up the atom's nucleus. But the electron is located in an energy level that surrounds the nucleus. And it is constantly moving within this energy level, moving about the proton and neutron that are located at the center of the atom. Now let's pause for a moment to talk about the different models of the atom. We are using what's called the solar system model. It proposes that the atom is like a small solar system, where the nucleus is at the center of the atom, like the sun is at the center of the solar system, and that the electrons orbit around the nucleus like the planets orbit around the sun. We are using this model because it does a good job of explaining basic chemical reactions, and it is easy to understand and picture in the mind. However, it's not a good representation of the true nature of the atom. If you want a much better idea of the true nature of the atom, you will need to use the quantum theory model. The quantum model of the atom tells us that the atom is much more complex than we can even imagine. For example, with the solar system model, we think of the electrons revolving around the nucleus of the atom. But the quantum theory model tells us that the electron does not really revolve around the nucleus like planets revolve around the sun. Instead, the electron forms a cloud around the nucleus, a probability cloud. Well, probability clouds are much more difficult to understand, aren't they? So we are going to stay with the solar system model, and it will work fine for our purposes. But it is important for you to remember that the model that we're using is a very simplified picture of the atom. And we're using it because it is a much easier way for us to understand chemical reactions. Okay, is all of this beginning to sound familiar to you? Well, just to make sure, let's recap. The proton and the neutron are located at the center of the atom and are called the nucleus, while the electron, according to the solar system model, orbits the nucleus, and the orbit is called an energy level. We also know that the proton has a positive charge, the neutron has no charge, and the electron has a negative charge. Now here is something that you may have forgotten, but it is very important. The positive charge of the proton and the negative charge of the electron are equal in strength. Both charges are 1.60 times 10 to the minus 19th coulomb. This is really an amazing fact, especially when we remember that the electron is 1,840 times smaller than the proton, and yet the electron's negative charge is of equal strength with the proton's positive charge. If these two charges were not equal, matter as we know it could not exist, and therefore we could not exist. For our purposes, it is not necessary for you to remember the actual strength of the charges in coulombs. However, it is necessary that you remember that the negative charge of the electron is exactly equal in strength to the positive charge of the proton. Because these charges are equal, we can talk about them in a more simplified way. We can refer to the charge of the electron as one negative charge, and we can refer to the charge of the proton as one positive charge. When we say that the electron has one negative charge, it is understood in chemistry that the strength of the charge is equal to 1.60 times 10 to the minus 19th coulombs. And when we say that the proton has one positive charge, it is understood in chemistry that the strength of the charge is equal to 1.60 times 10 to the minus 19th coulombs. So from now on, we won't worry about the strength of the charges. We will just focus on the number of the charges.